How's everybody doing out there? It's Mr. Kamiyama again. We're going through our journey of exponents, right? Now we talked about multiplying monomials. We talked about power of a power. We talked about when we take multiplying monomials with the power of power and when they're combined, how to do them, how to get our answer, how to simplify those. But what happens when we're talking about dividing monomials? Okay, it's a little bit different, all right? Now let's take a look and see what we got here. Here I got x to the fifth divided by x to the third. Now I know what some of y'all thinking. Uh-oh, Mr. Kamiyama, I'm talking about fractions. And some of y'all think fractions are scary. Okay, some of y'all probably ready to stop this video and say, forget it, I'm just gonna guess. Please don't do that. All right, fractions are not bad. They're not scary. Okay, when we're talking about fractions, don't think it's some kind of horror movie or something. It's not. Fractions are beautiful, people. Fractions are lovely. And look how pretty these fraction is right here. X to the fifth over x to the third. I love it. Now, in order to divide monomials properly, what I want to show you guys is how to take this exponential form, convert them to factored form, and show you how to just do this properly before we start trying to use some kind of special rule that we're going to learn. Okay, so take a look. If I were to make this fraction, which is in exponential form, meaning that it's written in exponents, if I were to take this and write it in factored form, now what does that mean? What does this x to the fifth really mean? How many x's do I really have here? I take x and I multiply it to itself 5 times, right? So that's going to be x times x times x times x times x. Look at that. 1, 2, 3, 4, 5. I have 5 x's there because I got 5 x's here. Okay? Exponent of 5. How many x's do I have on the bottom in the denominator? 3, right? Because x to the third power is going to be x times x times x. Now, what we do whenever we're trying to divide monomials, it's kind of like reducing fractions, okay? If you got a factor that's the same on the top and the same on the bottom, okay? If you divide them, you're going to get a 1. For example, 5 divided by 5 is 1 all day, every day. So the same thing is here. X divided by x, guess what? Is 1. Even though they're variables, it don't matter. You use the same concept. So if I got an x over x, I can just cancel those out, okay? Because I'm going to be left with a 1. Now, do I have any other x's I can cancel out? Well, I got one here and one here, so yep, I can cancel those out as well. Look at them, gone. Anything else? You're right. One here and one here. Let's get rid of those two. Now I got an x here. Can I cancel? No more x's on the bottom. Now some of you guys may say, wait, but there's an x here. Can't we just get rid of those? No, because they're both in the numerator. They're both on top of the fraction. You can't do that. So what our answer is going to be is anything that's left over. So if I look, what is left over on top? An x and an x. 2 x's. So how can I write that using exponents? X squared. Because there's 2 x's, my exponent of 2, and we're multiplying, right? So x times x is x squared. And what's left on bottom? Now think now, folks, if you cancel everything out on the bottom, does that mean you're left with 0? Because I know that's what some of y'all thinking. No, just like when I said that 5 divided by 5 is what? Is 1. So when you cancel everything out on the top or the bottom of a fraction, you're always left with a 1, still a 1. There we go. So x squared over 1. Now, if you take any number and you divide it by 1, you know what happens? You get the same number. So x squared divided by 1, people, is just x squared. And that's my answer, x squared. I'm done. Now, if I look real quick at this problem right here, the OG original problem, and I know that my answer is going to be x to the second power. I just know it. Do any of you guys look at this and try to see if you can think of a quicker way to get to x to the second power instead of doing all of this hocus pocus? What else can we do? Look at your numbers. Look at your exponents, people, specifically. You got 5 and 3. What can you do with the 5 and 3 to make a 2? Subtract. If you look here, we had 5 x's. We subtracted away the 3 x's down here at the bottom because these are like terms. And we're left with just these two x's here. So what we can really do is you can take your exponent up here and subtract away the exponent down here, which is 3. 5 minus 3 is 2, right? And when you do this, you can cancel out that term there. And so 5 minus 3 is 2, so x to the second power is your answer. Okay, now I had to show you that to properly show you how to divide those monomials. Okay, now so just subtract exponents. That's pretty much what we're doing. Okay, but of course I can do these all day and these would be simple. Okay, but let me give you a toughie real quick. What if you got this? Watch, I'm not even going to erase, just pay attention. What if I got a to the 5th over a to the 5th? Okay. Now, if we do the same thing we did here, we subtract. So we take this exponent right here and we subtract it away from this. And remember, we cancel that out. What's 5 minus 5? 0, right? So that means that we got a to the 0 power. Now, what you guys should know, because we've talked about this before, okay, is that whenever you have any number or any variable raised to the 0 power, you always get the same answer. Okay, your answer will always be 1. Once again, anything raised to the 0 power will always be 1. So therefore, when you have a problem like this, a to the 5th divided by a to the 5th, it's just going to be 1. That's your answer. Okay, don't think, well, 5 minus 5 is 0, so the answer is 0. No, remember, anytime you cancel everything out in a fraction, you're always left with 1. Okay, can't forget that. All right, so now we got some of these things out of the way. Let's take a look at a more difficult problem. All right, I want everyone to please pay attention to this because this is going to be a toughie. All right, so everybody take a look at this next problem. Oh my goodness, look at this. 7 x to the 8th, y to the 5th, all divided by 3y, and x to the 6th power. Oh my goodness, look at that. That's a toughie. All right. Because now we got different things, right? We don't just got a variable over variable. Now we got coefficients up in front. We got extra variables, right? We got a lot of stuff going on. So this is what I do. This is how I do a problem like this, okay? The first thing that I do, because I always look at this in a step-by-step type way. First thing I do is I look at the coefficients, right? That's the numbers in front of the variables, 7 and the 3. And I ask myself, can we reduce 7 and 3? Is there a number that goes into 7 and 3 evenly? It's got to be the same number. Answer is no, right? There is nothing that goes into 7 and 3 evenly. So therefore, there's no reducing the coefficients. We leave them alone. But now look, this is where it gets fun. Because what I'm going to do now is I'm going to look at my exponents and my variables and say, okay, does every variable have an exponent? If not, what are we going to give it? A 1. Doing that, giving it the 1, people, I'm telling you right now, is going to make things a little bit easy for you, okay? Now, let's start at the top. This is what I like to do. Please listen to me, pay attention. I got x to the 8th. In the denominator, do I have an x in the bottom? Look, 3y, it's right there. So this is what I do. Now, this is the confusing part, so pay attention. I got an 8 and a 6. Which exponent is smaller, 8 or 6? The 6, right? So this is what I do. I cross off this x to the 6th power, and I take this 6th power and I subtract it away from the 8. So what's 8 minus 6? It's 2. So this is going to become a 2. Okay? Now, look at the next one. You got y to the 5th. Do you have any y's on the bottom? Yes, you do. You got y to the 1st. Now, which exponent is smaller? The 1 or the 5? the 1. And because the 1 is smaller, you cross this off and you take this 1 and you subtract it away from the 5. Now, what is 5 minus 1? It's 4, right? And I like to cross this off so I don't get myself confused too much. So now I got all this mess here, right? Look at this. But now I put an equal sign and I ask myself, what's left upstairs? What's left in the numerator of this fraction? I got a 7, so I put a 7. I got an x to the what power? To the second power, so I write this down here. And then I got a y to the what power? To the fourth power, so I put y to the fourth. I cleaned up the top, okay? It's kind of like sweeping away all the trash. I swept away all this stuff that's crossed off. What's left on the bottom? Got a 3. Do we got a y? Any y's left? Nope, crossed it off. Do we got an x left? Nope, crossed it off. And now what we got is we got this problem right here. We got our answer. But the question is, are variables written in alphabetical order? Yep. So that's my answer right there. 7x to the second, y to the fourth, all divided by 3. And that's as simple as we can get that fraction. Okay, that's as simplified as we can go. All right. Now, I know for a fact that was probably confusing. I get it. That's why I'm going to show you one more. Here we go. Here we go. One more real quick. Let's take a look and see if this one, you know, maybe some of you guys will understand this one again. Here we go. All right, here we go. Watch now. So here we go. First thing, let's take a look. Oh my gosh, this is going to be a fun one. I mean, this is going to be like Disneyland right here. 10, A, B to the fourth, C to the fifth. Look at this. Man, that looks like good times. 8, A to the third, B to the fifth, and C to the third power. Man, that's good stuff. All right. So let's take a look at this. Remember, now this is big. I understand. Looks long, looks hard. I got that. It does. Okay. But if you just take each step and go step by step, it's not that bad. First off, somebody tell me. Look at the 10 and look at the 8. Can we reduce the 10 and the 8? Is there a number that goes into 10 and 8 evenly? The same number. Okay. 2 does, right? 2 goes into 10 and 2 goes into 8. How many times does 2 go into 10? 5. So look what I do. I cross off the 10 and I make it 5. Now the reason why I do that, because I divided that 10 by 2, because 2 goes into 10 and 8. Now how many times does 2 go into 8? 4 times, right? So what we did there is we reduced our coefficients. That's the first thing you want to do. You always got to look at your coefficients and try to reduce them, okay? So we got 2 goes into 10 5 times, 2 goes into 8 4 times. Look to see if you can reduce again, because sometimes you can. 5 and 4, nothing goes into those, right? Evenly. Not the same number does not go into 5 and 4, except for 1, but we don't ever reduce with 1. Now, so we got those coefficients taken care of. The next thing we do is now we're going to ask ourselves, do I have does every variable have an exponent? Well, let's take a look. Does every variable have an exponent? This A does not, so we're going to put a 1 there. Now remember the questions. Take a look at your A. You have an A on top and you have an A on the bottom. Question again, which exponent in your A's is smaller, the 1 or the 3? The 1, right? So look at what we do. I'm going to cross off the A to the first on top. And then what I do with this exponent of 3, I'm going to put a -1. Because I got the 1 from right here. That's the exponent with the A on top. And so 3 minus 1 is what? It's 2. So I'm going to put a 2 here and I'm going to get rid of that. My A's are taken care of. Now let's take a look at the B's. Look now. I got B to the 4 and I got B to the 5th. Which exponent of the B is smaller? The 4 or 5? The 4, right? So look what I do again. I cross off the B to the 4. And then what I do with this 5 is I'm going to subtract away the exponent that was on top, which is 4. Now what's 5 minus 4? 1. So I'm going to put a 1 here and I get rid of that. Now last, we got to look at our C. Okay, now if I look at my C, which is smaller? The fifth power or the third power? The third power, right? So look, I'm going to get rid of the C on the bottom. It's gone. So what's 5 minus 3? 2. So I get rid of this. This becomes a 2. And now if we look, I got a lot of junk on the board, right? Remember what I said? We got all this up here. We're going to sweep away the trash. We're going to sweep it up, right? Get rid of it so we only have what we need that's left. So take a look. This is what our answer is going to be. It's going to be our final answer. What's left upstairs? What's left on top? We got this 5. Put it down. Do we got an A left? Nope. Do we got a B left? Nope. Do we got a C left? We do. C to what power? The second power. So we put a 2 up here. Next, look at the bottom. Look at the denominator. What's left on the bottom? We got a 4, so we put the 4 here, right? We got the 4. Do we have an A left? Yup. A to the what power? Second power. Do we got a B left? Yup. To what power? First power. And do we got a C left? Nope, don't need it. Okay. Now, let me tell you something about this answer. If we looked at this answer right here, and let's say we were doing like a multiple choice test or something like that, you would not find this answer here. You know why? The reason why is because when it says simplify, what simplify means is you want to take whatever you started with, and it's almost like you want to write the simplest form is going to be the form that uses the less amount of ink or the less amount of pencil if you're using pencil. Okay, so I use too much ink in my answer here. And what I use that's too much is this B to the first. Whenever you have anything raised to the first power, you really don't need it. Okay, so I'm going to rewrite my answer correctly. And this is the way it's going to be written correctly. Take a look. On top, it's still going to be 5C to the second power. That doesn't change. But on the bottom, it's going to be 4A to the second. Do I have to write the 1? No, you don't. That's the part you don't need. So to write it in simplest form is when you write it with the least amount of ink. And so my answer is right here. 5C to the second over 4A to the second times B. All right. Now, was this hard? Yeah. Confusing? A little bit. All right. So this gets a little trickier. All right. So dividing monomials is a little bit trickier, but just remember the first thing you want to do, just to recap, you want to reduce your coefficients, your numbers in front. You want to reduce them. After that, look for the smallest exponent with your variables that are the same. The variables have to be the same to do this, by the way. You can't be taking an A and a B and trying to do this. Don't work. It's got to be 2 A's. Okay. So then you look here. Okay. You get rid of the smallest and subtract away the smaller exponent from the bigger one on the other to get your answer. All right. So I don't know. Hope this made some sense. Like I said, this is confusing. But if you know, have questions or anything, please let me know. Y'all have a beautiful day, and thank you guys so much for watching.